Here we are at our example 2a from our 2.4 number 1 set of notes. We're asked to write an equation for the line that contains 2 points on it. Now, in just looking at this, we're trying to create the equation of the line, and it has to pass through these 2 points. Now, an equation of the line, we know from our previous set of notes that we have y equals mx plus b. So we have these, this is again our equation of the line in slope-intercept form, and so we're trying to endgame write it in this y equals mx plus b. Now, in just looking at this, we have 2 points. So just starting out, what we can always do with our 2 points is go ahead and graph them. So we have the point 4, 0. So 1, 2, 3, 4, 0. And then 2, 4. So 2, 4 is right there. Right now, all we've done again is just graph these 2 points on our xy coordinate plane. Now, anytime that we have 2 points like this, anytime we have that scenario, we can go ahead and first find what is the slope for this. What is our rate of change here? Well, you could just look at the graph and see that we are going down 4 and running 2. And so you could say, well, my rise over run here comes out to be -4 over 2 or -2. But this being algebra, we do have to go ahead and prove this scenario that it does come out to be -2. So if we think back, we can go ahead and again, anytime we have 2 points, we can go ahead and first find the slope between those 2 points. So our slope formula again is y2 minus y1 over x2 minus x1. Now it does not matter which one is x1, y1 and which one is x2, y2, as we've mentioned before in class. So I'm just going to go ahead and let this one be x1, y1, and this one be x2, y2. Again, as long as all the algebra is correct, it will not matter. Going ahead then and substituting in these values, looks like our y2 value here comes out to be 4. Big minus from the formula. y1 here is 0. This is over our x2 value. Here it is 2. Minus, from the formula, our x1. There he is 4. So when we simplify things, we have 4 minus 0 on top. That comes out to be 4 over 2 minus 4 comes out to be -2. Positive 4 divided by -2 comes out to be -2. So that is, again, just the algebra on why our slope is -2. So again, we have found our slope or our m value. Now in looking at this, we are given the equation of a line in slope-intercept form, and we are now having our slope and a point. So we're very much like in the scenario we were in example 1. We actually kind of have an advantage here. We actually have 2 different points that we can choose from. For the sake of just seeing things with bigger numbers or multiple numbers, we'll go ahead and do this one. So again, we know an x, a y, and our slope. All we're going to go ahead and do is plug them into here. So it looks like our y value comes out to be 4 equals our m, -2, times our x, here he is 2. And then plus our b. Unfortunately, we don't know what b is yet. Simplifying things out, we end up with 4 is equal to -2 times +2 comes out to be -4 plus b. And again, we need to solve for b, so we're going to go ahead and add 4 to both sides. Four plus 4 gives us 8 on the left side equals b on the right. Rewriting our equation now, we end up then with y equals our slope, -2, x plus our y-intercept that we just found, 8. So this would be our equation for the line. Let's go ahead and actually, while we're here, go ahead and prove that it's going to be the same line for this point, 4, 0. So going ahead and plugging in our y value, 0. Zero equals our m, here he is, -2, times our x value. We said that it was 4 plus some b. Again, really all we're doing with this second one, we should probably say that this is our 2, 4 point. And then here we're going to go ahead and try it with our 4, 0 point. Just to kind of, again, reiterate that we are getting the same exact line. So 0 is equal to -2 times +4 comes out to be -8 plus some b. Solving for b, we would go ahead and add 8 to both sides. B is now all by himself on the right side equals 0 plus 8 comes out to be 8. Again, rewriting the equation of that line, y equals our slope, -2, x plus our y-intercept that we just found, 8. So notice how they, again, are exactly the same, regardless of which point we chose right here. And that makes sense because if we look at the graph, notice it's supposed to work for either of these 2 points because both of these points lie on this line. Now again, we want to keep x and y just as those variables because there are, again, many points that this will work for. So for example, right here is another point that it would work for. Right here, it would work for. Okay. So again, though, that is example 2A from our 2.4 number 1 set of notes.